Here's 5.6, day 1, focusing on solving quadratic equations using the quadratic formula. You should have seen this quadratic equation and quadratic formula in Algebra 1. I do recommend that you write the quadratic equation down. That's in standard form. ax squared plus bx plus c equals 0. That is standard form. In order to use the quadratic formula, you must have it in standard form. The quadratic formula in this class, we ask you to memorize. We are not going to give you the quadratic formula on a test or a quiz. There are different ways to memorize it. Some teachers teach you to sing a song. We can talk about that in class, what that song is. So go ahead and write down the quadratic equation in standard form and this quadratic formula. Then at the bottom it says a must be a positive number. It just makes it easier if you have a positive a when you're working with the quadratic formula. You don't have to divide by -1. It just makes it a little easier so you don't have to work with a negative in the denominator. And then make sure that you always are in standard form. All right, here's our first example. Use the quadratic formula to solve this quadratic equation for x. So we have a quadratic equation, x squared plus 5x minus 14 equals 0. We first want to look to see that that quadratic equation is in standard form, which it is. So we can go ahead and identify the coefficients that will help us for a, b, and c. So our a value is the coefficient in front of x squared, so that coefficient is 1. The b value is the coefficient in front of the x term, which is a positive 5. And then the c value is your constant, which is -14. Now we're going to go ahead and use this quadratic formula to solve for x. So I have the quadratic formula here again. You don't need to write it down. We can go ahead and just plug it in. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Be careful that you make it all over. Now we're going to go ahead and reduce. So -5 plus or minus 5 times 5 is 25. And then -4 times +1 times -14 is a +56. Divided by 2 times 1, which is 2. Now we'll reduce again. -5 plus or minus. Underneath the radical is the radicand. We add those numbers together and we get 81. Divide by 2. Now look at that square root of 81. Remember the worksheet that when we worked on reducing radicals? Square root of 81 is a perfect. Square root of 81 is 9. So we have plus or minus 9 over 2. Now we can break up the equation into two equations because we have -5 plus 9 over 2 and x equals negative 5 minus 9 over 2. So x equals negative 5 plus 9 over 2, and x equals negative 5 minus 9 over 2. So we have to reduce those fractions down. So negative 5 plus 9 is 4, divided by 2 is 2. So there's one solution. Then over here, negative 5 minus 9 is negative 14, divided by 2 is negative 7. So you have two solutions, x equals 2 and x equals negative 7. You could plug them back in separately into the original quadratic equation and solve for x. Let's practice a second example. Here's another quadratic equation in standard form. We're going to identify the a, b, and c. If you want to, you could divide all of the terms by a negative 1, so that leading coefficient is a positive. I'm just going to show you as if we leave it alone. So we identify the a, b, and c. So there's your a, there's your b, and here's your c. And now we plug it in to the quadratic formula. X equals negative b plus or minus b squared minus 4ac all over 2a. Now we're going to reduce. Nine times 9 is 81. Negative 4 times negative 3 times positive 5 is a positive 60 over negative 6. Now reduce again within the radical. Over negative 6. Now look at square root of 141. That's a number that is not factorable down to break it down into reducing radicals, so we can just leave that answer alone. We do have two answers. We have negative 1 plus the square root of 141 over negative 6, and then the negative of that. So you can just leave the answer as it is. All right, here's example C. Here's a quadratic equation, and there's a hint. We want to rewrite this to standard form. So we have to bring that minus 3x and the 8 over to the left side. So we're going to add 3x and subtract 8. So now we have 0 left on the right. Then we identify the A, B, and C. And then we would substitute it into the quadratic formula. I'm going to skip that part since we've just done two examples very similar to that. If you want to finish the problem, you're welcome to do so and plug it in and find the two solutions. Here's our last example. Here's a quadratic equation. It looks a little bit different. It doesn't have a c term. So if I rewrite this as x squared plus 3x, there isn't the c. So I'm just going to put a 0 in for that c so I don't forget about it. So now my a, b, and c are a is 1, b is 3, and c is 0. And now we plug it in to the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2c. A. And now we're going to reduce. -3 plus or minus. 3 times 3 is 9. And then -4 times 1 times 0 is just 0. Reduce again. 9 plus 0 is 9. Now we can reduce that radical. That radical, when we square root 9, we get 3. Now since this is an integer of a plus or minus 3, we can go and break it up into two solutions to get our integer values. We get x equals -3 plus 3 over 2, and x equals -3 minus 3 over 2. Reduce, -3 plus 3 is 0, divided by 2 is 0. So there's one solution, x equals 0. Then, over here, -3 minus 3 is -6, divided by 2 is -3. So there are your two solutions, x equals 0, x equals -3. And you can plug those back into the original equation and solve for x. Here is the homework for 5.6 day 1. 2 through 7, 37,